choice. But the beginnings weren't so smooth. I kept struggling, trying to understand various concepts in Scala, and one of the things that confused me the most was implicits. So there were times when I thought, okay, I got this. I finally understand implicits. And then sometime later, a week later maybe, I came upon some other usage of implicits in some other context, and I was totally lost as well. So I had to circle back to my more experienced colleagues and ask them, I know we have already talked about it, but maybe can we sit together one more time, and can you explain to me what the author of this code had in mind? Fortunately, my colleagues were very patient. So I got through this difficult phase, and I didn't give up Scala completely. But I kept thinking, why does it have to be so difficult? If it's a concept that I kept finding in my projects that seems to be essential to the way I write Scala code, why is it so hard for me to grasp? So when I heard about Scala 3 and I learned that the concept of implicits was going to be redesigned, that got me curious. I wanted to know if maybe that's a change for the better in my view. So this is how this presentation came to be. I would like to share with you what I have learned and how I understand how we should write implicits in Scala 3. So I will tell you why we need implicits, what the problems in Scala 2 were there for me and generally. And the main part of the presentation is I will show you a couple of use cases, the way I see implicits being used, and the code in Scala 2 and in Scala 3, how we achieve the same thing a little bit different. And also I say a couple of words about migration. So what are implicits? Generally, implicits are a major language feature and a very powerful feature. They let us express and make the code do what we want it to do. And they are being used to define many things, but what's common is that they provide some kind of context, so that when you write the code, you don't have to express everything explicitly, but some of the things the compiler can infer from the context. So this whole concept is called conceptual abstractions. But the implicit keyword, apart from providing context, is also used in Scala to achieve various different or a little bit similar but different things. And that's also adding functionality to your types, defining type classes, which in itself are an important language feature, provide implicit conversions between the types, specify dependency injection, express capabilities, compute new types, and prove to your compiler some relationship between the types. So for all that, we had the implicit keyword in Scala 2. But some of the problems were that the implicit keyword can be found in the language next to various language constructs. So we could have implicit parameters and arguments, values, objects, defs, and classes. And some of them were used to define common things, but some of them were used to define some other things. So it's not enough to just learn the implicit keyword once, because you had to learn various idioms or patterns or ways how you solve and achieve different things using this implicit keyword. And also, one of my problems were the imports. I seemed to always be missing some import. So that, for example, I had some code working perfectly in one file, but then when I copy it to another file, it doesn't compile. Like the compiler is very unhappy about it. And often the cases is that I'm missing some specific import from this first file, and when I copy it back, copy it over to the other file, suddenly the compiler is happy and everything is perfect. Or sometimes I just remember I used to write code like that, but what is the import that would make the compiler again happy? So that was a bit problematic for me. And sometimes, I guess it may be the other way around. So I'm importing some implicits, and I don't really know about it. So for example, this can happen with implicit conversions, that you have a very broad import, which also brings you some implicit conversion between the types, and then your compiler treats some type as another type, and it does what you don't really expect. So that can be a problem. And for all these reasons, probably implicits can be a bit tricky for a newcomer to the language who just wants to get their job done. So where does Scala Free come here? So Scala Free, what I love about it, is that the creators of it have decided to listen to us, to listen to the users, to see how the libraries are written, to see what the complaints are, what were the tricky points. And they have decided to address those tricky points to make the language easier to use, more convenient to use in everyday life. And that's probably not a surprise that implicits have been selected as one of those tricky points. So this concept was redesigned to the point that the implicit keyword is gone from Scala Free altogether. And what we get instead is we get a couple of different language constructs, and each of that does one thing and does it well. So let's see that in action. My 7 use cases, these are the things that were most important to me, or the patterns that I see being used or I used in my projects, is the basic one of providing context, adding functionality to types, defining type classes, providing implicit conversions, and I'll also say a bit about imports, unused names, and compiler errors. So let's start with the simplest use case of providing context. Let's say we want to define a future. So when we write our code, what we are really most interested in and what the reader of the code is interested in is the body of the future. So what should happen asynchronously? So they read just the body. But we know that it's not enough. If we have some kind of asynchronous computation, we need to have some thread pool, or in this case, some execution context. So if you take a look at the apply method in the future, you see that apart from the body, you also have this implicit parameter list, which tells you that you need to provide the execution context. But you don't want to write it here every time and every time you are defining a future, because this is, as I said, some context which you can maybe define once and let the compiler just fetch it wherever it needs. So when I write code, I tend to think about it as some kind of a story or some kind of a message that I'm sending to the future reader, and maybe the reader is not exactly interested about the execution context every time. So the way you do it in Scala Free is you can provide an implicit val, and then the compiler knows that this is the execution context that needs to be taken. So how is it different in Scala Free if I'm saying there is no implicit keyword? We have this using and given pair. So the code that we are writing is the same. We have the body of the future. And if you see the apply method, then we also have this implicit parameter list, which in this case, in Scala Free, is using the using keyword. So for this method to run, the compiler needs to use some kind of execution context. And in the place where we provide it, we use the given keyword. So here we are giving this execution context to the compiler, and it can take it wherever it needs to be used. And this using and given pair is the basic and most important thing that you will need to write contextual abstractions in Scala Free. And we will see it also later in the presentation. So let's move on to adding functionality. To see why we might need it, let's imagine some sample domain. Let's say that we are in the domain of providing websites for people who read books, so that you can add the books that you have read, and you can have reading challenges, so that at the start of the year you decide, this year I'm going to read 10 books or 20 books. And then as you go, you add the books, and the website tells you if you are on track or you should read more. So let's say that's all fine. But then your product owner comes to you and tells you, this is good, but some of the people add books that are very short, which makes their challenges very long, and they finish it early, and it's not so much fun for everyone. So we need this kind of qualifies for challenge method. So let's say we have our book type, and we want to add such a method for it. However, the problem is that the book type is specified elsewhere, somewhere in another package, or it's owned by another team, or it's defined in a place where we have no control over it, so we cannot really add the method. But we are writing in Scala, we are very powerful, and we can do things like that. So we can add functionality to clause types. And in Scala 2, we did it with the implicit keyword. So what you needed was you needed to define an implicit class, give it some kind of a name, which doesn't really matter, but it's parameterized by our book type, and then we define this method. If the number of pages is greater than 20, then the book qualifies for the challenge, and if it's very short, then it doesn't. So if we have such implicit in scope, then the code at the bottom compiles, and we have added this method to the type which comes from somewhere else. We say that in our scope where we are interested in it, we are giving it this method. So that's a very useful feature. Now, how does it look in Scala 3? So the code that we want to achieve is the same, and the book is still defined in another package. But the way we define such adding of the functionality is we use the new keyword in Scala 3. That's the extension keyword. And these are called extension method. So you say you're writing an extension for the book type, and the method, again, the body of the method is the same. So what I love about it is that it's a really simple concept for a thing that you might need to do every day. It's something that really is simple and is simple when you read it. So that when the reader of your code sees this extension keyword, they already know what happens. They know that it's a method being added to some otherwise closed type. So that's an example of a thing which is added to do one specific thing and to do it well. And then, now let's move to type classes. So as I said, type classes are important, but to be honest, I didn't feel the need of writing a type class, I think until the 5th year of my writing Scala, when I was doing something and I thought, okay, maybe I need a type class. Of course, I was using it by means of libraries, but I wasn't really aware of it. So why might you need a type class? Let's imagine we are still in our domain of the book website, but your product owner again comes to you and says, yes, some people read books, but some people read magazines, and they would also like to take part in the challenges. But how do you compare reading 10 books and 10 magazines? So let's redesign it a bit, and let's now say that each user has their kind of a score, and that a score for the book is the number of pages of the book, and the score of the magazine or an article in a magazine is always 1. So for that, we would like to have a code like that. We have the book type, where when we count the current score and add a book, then the current score grows to 600 in this case. And we have the article type. And again, we would like to add an article to our score and have it being increased by 1. So if only this book and article had a common parent, so for example, it would come from the same trait, it would extend the same trait, we could maybe add a method to the trait and handle this behavior. But it turns out, again, we don't really have control over these types, and they seem to be completely unrelated. Even though in our part of the system, it's almost the same thing, somehow they are unrelated. And this is why we might need type class to define so-called ad hoc polymorphism. So we add common behavior to unrelated types. And the way we define it is we need a trait which is our behavior. So we have the scorable trait because our behavior is being scored. It's parameterized by some type. And then the definition of this behavior is the score method. And then we just need to define these behaviors for our article and book types. And the way you do it in Scala 2 is with implicits. So you could have implicit vals, or actually you can do it with implicit objects or devs, but let's stick with implicit vals. So you have this behavior implemented by implementing this scorable trait. So here it's parameterized by the book type, and for the book type, the implementation of the score method is the number of pages. And we have the behavior implemented for the article type, and then the implementation is always just 1. And the way we might use it is we might use it here in the add item method of the current score, so that this method can work for an items which are of a scorable type. So it can work on every value or class which has the scorable behavior. And the way we use it here is we just take the current value of the score, and then here this implicitly of scorable tells the compiler to just fetch the appropriate implementation according to the type it was called with. So it will bring either this or that implementation of the score method. And if you don't like this implicitly of scorable, then there's also an alternative way to do it. You can have an implicit parameter list, and then you have this scoring parameter which you can use, and it will work the same way. So now how do you define a type class in Scala 3? What you want to achieve is the same. You are trying to write the same code, and the implementation of the behavior is the same. So it's again a scorable trait, parameterized. But the way we add implementation is given and using. So the pair that we have already talked about. So you're providing or giving a scorable behavior implementation for the book type with this implementation, and you are implementing the type class scorable of article for the article type. And you use it in a very similar way. So you can again have the add item method for the scorable instances. And here, instead of this implicitly, you have the new summon keyword. So even as the prefix, this implicit keyword doesn't exist anymore, because implicitly gets transformed to summon. So that's the new thing. So again, if you see summon, you know that the author is telling a compiler to fetch the appropriate implementation of the type class. And very similarly, you can use the other syntax with the separate parameter list, and then you can just say scoring.score. So that's how you can define the type class in Scala 3. Moving on, let's talk about conversions. So let's say we are still in the book business. We are working on our book types, but also somewhere else there is a print method defined. Print or display, which displays the value of the book in some very special way which you would like to use. However, your problem is that the print method is defined with the item type, and you are working with the book type. And you know that in your head and in your part of the project, it's really the same thing, but again, you don't have control over the item type or the print method somehow. So what you may want to do is you may want the compiler to understand that whenever you want to print a book, you will provide some kind of a way for the compiler to know how to treat the book as if it was an item. So that's why you might need implicit conversions. And the way you would define it in Scala 2 is you provide an implicit def. So let's call it book to item, even though the name doesn't really matter. It operates on the book type and returns the item type. And here is our recipe for how to transform one to the other. So just use the item constructor. So that implicit conversions are a bit controversial in the sense that sometimes it can be a bit confusing because you are using something implicitly which you may not want. But let's see that. So for Scala 3, when you have the same problem, you would like to treat books as if it were an item, and you don't have the implicit keyword. What you do is you are implementing the conversion type class. And this is a scala.conversion class parameterized by the source type and the item type, a special class that you use just for that, for implicit conversions. So it's something that has one apply method. It takes source type, returns the target type. So in our case, the implementation is the same. So what is nice here is that whenever, again, the reader of your code will see the scala.conversion class, they will know instantly what happens. They know that we are providing to the compiler a recipe to treat one type as the other. So that's making implicit conversions a little bit more explicit. And now, the thing about imports. So in Scala 2, this code compiles just fine. So we are just importing everything from the implicits package or object, and then you are writing a future. It's all fine because implicitly the compiler can fetch the execution context from that import. But in Scala 3, such code wouldn't compile. And why is that? That's because if you want to import the givens, so the implicit stuff from this package, you need to use this .given syntax. And only then all the given things or the given clauses from that package will be brought into scope. So only then such code will compile. So again, this is making the implicit imports a bit more explicit, because if you have a long list of imports somewhere and there you are looking for that import that will fix your problems, you just need to see which ends with given. And if you really do want to import everything, then you need to use a syntax like that. And now, unused names is something that is very, very small, but I really like it. That's because naming things is hard, generally. So let's say we have our books, we have a list of books, and we would like to sort them. So if we don't want to reinvent the wheel, we are using the seek_ops trait. So there is this sorted method that we can use. We just need to provide the implicit ordering in Scala 2. So the way we do it is, again, implicit val, which to the compiler we are providing the recipe that the ordering for our book type is like that. So we just compare the titles. And we need to think of this, this value, name, even though it's not used by human. You don't read it elsewhere, you just have it there in the definition of the val. And in Scala 3, you can do it similarly. So here with the using clause, using parameter list, when you are providing it, you can give the name, or you can just omit the name. And that's what is very close to my heart, because for the compiler has everything it needs. It just has the types, and you are providing the recipe. But when you are a developer and you are writing your code, it's one less decision to make. Because if you have names, then, and if you have a team, you have to agree with your team. What names do you use for implicits? Should they be meaningful, or should they be very short one-letter names? And then this colleague which takes great care about the quality of the code starts a discussion in the PR, what should be the name of the thing that which isn't even used. And sometimes I am that colleague. So I'm very happy that sometimes I don't have to start that discussion. We can just omit it whenever it's not used for the human, by the human. So that's anonymous givens. And also the last thing is compiler errors. So something that I saw very, very often when I was struggling to learn implicits. So in Scala 2, this is an example of a missing implicit. So could not find implicit value for evidence parameter of the scorable of book type, but we don't really know where. And sometimes in a long list of chained calls of methods, I was really lost which one of the methods really needed that implicit. Sometimes it's not clear. But what Scala 3 will do is we'll try to tell you more. So it tells you that this kind of parameter was not found for parameter scoring of method addItem in class current score. So we can instantly know and check the documentation what kind of implicit and why is needed here. So that's something that I really, really like. And also sometimes the compiler will try to be even more helpful and try to suggest what might fix the problem. So as the previous discussion during the panel, sometimes the error handling in terms of the compiler can be a great help for the developer. And in the case of my problems and of my struggling with implicits, whenever I got the error where I have no idea how to handle that, I would like to either go back to my colleagues or check for the documentation. It would get me out of my flow, and I could forget what I was really trying to do, because now I have this problem with the missing implicit, and I don't know where to start. In Scala 3, the compiler tries to be a little bit more helpful. So now, as these were the 7 use cases that I found the most useful and needed for my projects, let's talk about migration. So if the implicit keyword is gone, but still the contextual abstractions are so widely used in our code, then how do we migrate between those two approaches? So the nice thing is that they are completely interoperable, so that you can have the code using implicits, and it will just fine work well with the code with using and givens. So if you have a library that is already migrated and defined with the using and givens, you can use it using implicits. Or the other way around. If some other team in your project is still using implicits, but you want to try given and using, give it a try, then you can do it and it will work well together. You can even define it in the same file. Here using, here implicit, here given. Of course, it will be confusing, but you can do it. And this way, you can do the migration at your own pace. You can just move the parts where you want to try it out a bit quicker, but don't worry that it will break something. But sometime in the future, these will be deprecated. We don't know when. I think Martin, during his keynote, said that from 3.10, some things might disappear, and it might be implicits, but I guess nobody really knows when. So for now, you can still use the implicit keyword in your Scala-free code, or you can use the given and using and the conversion class and so on. But at some point in the future, the implicit keyword will be gone. So to sum up, what I love most about contextual abstractions in Scala-free is that I can use them to express the intention of my code. Not what language features I am using to achieve that goal, but what goal I am trying to use. So what's most important and most widely used is the given and using pair, but together with extension methods and the conversion class, I think they give you a little bit more convenience, a little bit more expressiveness for the reader of your code so that they know what you are trying to communicate. If you would like to know more about this, there's also a feature in Scala-free called context functions, which is related to that, but I haven't included it because it doesn't have a direct counterpart in Scala-free, in Scala 2. So it's a new thing, so you might want to check it out. And there are some resources about other Scala-free features and the ways how you might want to proceed with the migration, what steps to take, which libraries to start in the migration guide. And if you'd like to have a look at the types defined in this example, they are here in the GitHub repository. So thank you. That is all I have. If you have any feedback or comments for the presentation, you can scan this QR code or go to that link. The slides are also available there. And if there are any questions, I guess we have some time. Thank you.
Hello. Thank you for the presentation. One question. Martin, on his keynote, said that there is some adjustment of the implicit scope search in Scala 3. Can you say something about that? What was changed?
Right. So all I know is that the problem is sometimes with the order of the implicits which are fetched to your scope. Some things you have defined here in your objects, some things you have defined in the imports, and so on. And the way it was done initially was criticized a bit and caused a lot of confusion. I personally haven't experienced that. I guess I didn't have a lot of implicits defined for my Scala-free code. But yeah, I have also learned in the keynote that it has been fixed. So it's something to check out.
Thank you.
Any other questions? Can you put the previous slides?
Okay.
Okay, thank you very much for the talk.
Thank you.